Welcome to another test and teardown video. This time it's another Hameg scope, but it's not just an ordinary analog scope like we've already seen quite a lot of. This one is the HM205-3 20 MHz storage scope. And it's just not an ordinary storage scope. No, it's a digital and analog scope in one. That is something, isn't it? Look at this nice picture here, right? What happens if I hit the digital button? Ooh, did you see? Yeah, it moved a little bit. But also, I don't know if this is easy to see. But can you see there's a little bit of digital here? Yeah, I think I can see. Especially if I move it a little bit, you can kind of see where it goes in and out of the bits. I don't know if that's really easy to see. Let me see if I can turn down the brightness a little bit. Is it easier to see now? The digital interference, or the digital resolution, should I say, right? So I think this is 8-bit. Let me crank up the brightness a little bit more. So in digital storage mode, as far as I understand, what they do is they got an AD converter that grabs the signals after the gain stages and all the analog stuff you got here, where you can, oh, there's a little bit of a, anyway, just after all the analog stuff. So there's an analog to digital converter and some memory for both of the channel, and it's all running in parallel. So it doesn't matter if you got two channels like this. See, still going to work, right? So dual or single mode. So, and then it just regenerates. It plays back the picture from the memory into the kind of the screen unit or directly to the CRT, right? So that's kind of how it works, and this is exactly why it is just one button to go analog or digital. So that is quite cool. Because of the sample rates, they made it so that you can go all the way up here in storage mode. But if you continue all the way up, as you can see here, I can just, now I am in analog mode, right? So I can just continue all the way up. And of course, the faster I go, I lose brightness, and then I need to add more, right? So this is how it works. And if I go to storage mode, now I'm in storage, right? So, see, oh, it kind of stops, right? And then we're back. Of course, if I got too much information on the screen compared to the sample rate, like what I try to show here, now I kind of go slower and slower. See, you got dots like this, and then the dot will move a little bit. So this scope also got dot connect mode. I don't know if it's easy to see here, but it's actually trying to move a line between the dots, but that is too dim, I guess. There's probably a trimmer where you can control how bright you want the dot joining feature to be. See, now it's on, now it's off. It's not that powerful, or I don't know if it's correctly adjusted anyway. So that is yeah, the dot joining mode. So why is this so cool with the digital storage mode? So let's go analog again, and let's change the input to a pulse signal like this. So now let's try and dial the trigger. Why is this not working? Hello? Okay, here we go. So now I got a signal, a tiny little pulse that is coming only once per second. And let's dial it down to 10. I don't know, there's something with the trigger. Sometimes it's not reacting. See? And then it's reacting to the changed time base. So, I don't know, there's some funny thing with the digital interface to the time base changes or something like that. So now this is a pulse that's about 10 microseconds. I intentionally made it super slow on the fall time, so you can see the dots, and then we can play with the joining mode. So this signal is more or less impossible to see on an analog scope. Let's try and go in analog mode and see if we can crank up the brightness, and then we'll see if there's anything visible. Yeah, I think you could actually maybe see this if we turn off all the light, and if we're really patient, we could maybe see the signal. But yeah, hey, this is exactly why digital scopes, they're winning, right? And also, look what I got. I got the printer. I haven't tried to power up the printer yet. There's a flat cable between the two units, and it is a Hameg kind of format. So I have no idea how this thing works, other than you can pull this out. And then the printer is only this tiny little piece. So maybe you just, okay, look. So this, I guess you put in the paper, and it somehow locks here. And then I guess this will be a thermal paper of some sort. And this is a roller. So if you loosen this, you should be able to feed the paper around those rollers and something like that. And then just stick it in again, and you're ready to print. And of course, when it got the image stored in digital memory, you should of course be able to transfer this image to this unit, and then select whatever picture you want and then print it out. I don't know what's going to be on this screen, but hey, let's just power it up and see what happens. I just don't have any paper for this. You need special thermal paper, so yeah, that's not so funny then. Damn it. So now I've disconnected everything, of course, and I powered up and connected the flat cable, and this damn thing is not powering up. I don't see anything, at least. And also, I am measuring the current consumption, and it is just 0.0. So we need to open this one first and see if there's anything we can do about it. So this is the printer unit with the scope removed. It's actually quite big. Of course it is made this big so the scope will fit on top, and they really made this quite nice. The feet of the scope fits click, and it is super stable, and nothing is gonna roll around and all that. And let's take out this, so we're not gonna break anything when we put it on top like this. As normal, I would assume you just take out these two screws, and then we're done. Oh yeah, I think this is 94. So that will be how old this unit is. And it was for 200. Hey, maybe we just check the fuse. Huh? How about we do that? I think I found the problem. And also, I think I found the reason for the fuse to be broken. Because this is only... why is this picture so bad? 315 milliamps. And supposed to be 0.8. Duh. So this is why it blew up. And it was thrown out because of that. That's not so intelligent, is it? So it was only the fuse. And the fun thing is, this printer only uses, 8 watts in standby? So why wasn't 315 milliamps enough? But anyway, all it says is paper out. Really nice and sharp display. So that's kind of perfect. It is not responding to any of the buttons, obviously because there's paper out. So I don't know if you need to turn it off while you pull the printer unit out to change the paper and stuff, I think I'll rather just turn it off and then pull it out. Anyway, I need to get some thermal paper before I can play with this. How many friends I got. A reel of paper is only a phone call away. Haha, now I can test this thing. Oh, it actually boots up and writes something on the paper. So test RTC is failed, battery low, and then it went into manual online mode. I guess I can just... Why do I hit print maybe? Oh, look at that! It actually did something on the screen. Whoa, look at that! Seems like it is working. And then I get all sorts of... And then you just pull it up. What do you know? That is exactly what I see on the screen. Yeah, I don't know why this is so cool. Can you imagine back in 93? Because this is the default date and time. So there are some batteries in here and a timer or a RTC and stuff like that. So obviously I need to open this and change the batteries. But isn't this just beautiful? It also said the zoom range and volts per division, time base and stuff. Wow, great! I love it. See, this is 20 megahertz, and it still trigger real good in the analog mode. And let's go down to 2 megahertz just to see the amplitude. So that was 2 megahertz, 20. All right. So yeah, I believe this is indeed a 20 megahertz scope in the analog mode. And if we go to digital, I have to crank this all the way up here, the fastest digital mode. Let's go digital, and then it goes real bad like this. 10 megahertz, 1 megahertz. So in 1 megahertz digital, what you can do is go in X10, but then it looks real unstable and it's not really useful. So that was 1 megahertz. Let's try and give it... Okay, this is 100 kilohertz. That is perfect, right? Yeah, 100 kilohertz, super perfect and very useful. And of course, we're gonna get all these. Ooh, cool, huh? It all comes up to sample rate. That is actually really nice. So this reveals the crystal, or the timing is accurate. Let's start with the printer unit first. It is designed really well, as we are used to with Hameg equipment. It's just really good. And there is of course a chassis connection to this chassis to the other chassis. So that is of course correctly done. And then there's a mains filter. And look at this huge transformator for 7 watts. That is amazing. And there's a shield or a guard between the primary and secondary that's also connected to a chassis. So that is done so they have no leakage capacity from mains to the secondary sides, because what they really don't want is AC voltages and AC currents when you plug or disconnect the flat cable between the two units. They also say disconnect mains cables when you plug or disconnect the flat cable. So that is of course why they do this. And here is, what is that? That will be the alkaline cells. That doesn't work. So this we need to, so it's like what? Just, okay, that was easy. Are they didn't puke or anything? Oh, lucky. So this is probably because they choose some really expensive professional alkalines. And we don't see any puke. I love it. That is great, because I really hate when I get electronics full of battery puke and it goes down to everything, and it's really terrible to maintain and to service. But all this is really good. I think maybe we have a start now. So what I think what I'm gonna do is I'm gonna leave the battery compartment empty, because it doesn't matter for me if I need to set the clock. So this is from 94, the printer unit, and here we got the I/O ICs. And what is that? I believe that will be high power drivers or something related to the thermal printers, because I don't know those chips. And that is of course the printer module, and there will be a Silex at 80. Isn't that pretty cool? EEPROM and a lot of RAM. And what is that, timer, right? And the display and buttons. Also what I saw, okay, let's see if I can show you guys this. So the power supply here, really big rectifier. So obviously the thermal printer is using a lot of power, but in pulses, and this is why everything is really big and strong. Look at the cables and everything here, right? They even made it so you can put in a bigger fuse, but I really don't like that. A capacitor directly up against a regulator like that. That is not good, because they don't really like heat. And what have you got here? The hottest spot, and here is where you put the capacitors. No. This is not good at all. Those capacitors are slow, and they should have been placed far away from anything that gets hot. And don't even put them right next to the rectifier. They can actually be a little bit away from the rectifiers. Yeah. What is that? So there's a switch. Well, this is okay for the thermal printer. And we've also got some capacitors under those. That will be the connector module for the printer. Other than that, there's not a hell lot to say about this beautiful printer. It is a huge PCB, and it's designed in '92. And it was manufactured in '94, this unit. But it really looks beautiful when you discard the capacitor placements. That was really bad. And again, the transformator is huge. And here we got really good thermal design, where it's mounted on some aluminium and it's directly connected to the frame and inner here. So that means we're not going to have a thermal problem. That is really good. EMC design, great. Oops. And of course, yeah, the same in the other end. That is beautiful. I'm really happy about this. And I will put it back together and maybe put a note on the back that says, well, no batteries inside. I took them out. So that means when you see the error, you know, oops, no big deal, no problem. So now we're inside the scope, and the bottom main PCB is a single layer PCB, just like almost all of the Hameg scopes that I've seen, and everything here looks very much like normal input amplifiers. That is a 2-layer PCB, and now it's full of SMD components as well. So that is a lot more modern design. I don't know exactly what they're doing with this capacitor. It was supposed to be standing up, but like this. Maybe they needed a little bit more or something like that. Or maybe this is a later repair, I don't know. This is the top of the unit with all the time base stuff here. Got a lot of switches and stuff from the front panel. Of course, this is the storage control. Goes to the digital board with all the storage components. We'll see AD converters, DA converters, so a lot of gal parts to control the timing and stuff. That's of course because they're really fast. I believe this will be the fast memory. So here we got some ADC and some DAC components and all that. I believe the trimmers here will be for the alignment between the analog and the digital part. So when you push the analog digital mode, as you saw, it was moving a little bit on the screen, and this is of course where you trim this so you don't see this as much. The mains transformator is a really good size, and it's perfectly mounted for good thermal connection to all the chassis parts, so that is really good. And this board is of course all the high voltage stuff. Here we are generating the positive and the negative, the anode and the cathode supplies. I believe this, what is that? There's an optocoupler, right? So this optocoupler is obviously for mains synchronization. And yeah, that is what I think we got here. And that is of course the connector for the printer. And it is connected to the digital board right here. So I think that concludes this lovely scope.